Hello there, this is Pavli G. This is just a demonstration of how to check the shared native libraries bundled with your Android APK from third-party dependencies. So dependencies like Minie-3 Android natives or Minie-bullet-physics library. It's actually it has a bundled native object file. So when you open your Android application, it opens Android Studio. Then you have the Android at the palette. At the palette of project, you have Android. We will change this to project. Then you're gonna have your main root module, and inside there are a couple of other modules there. So for example, we will actually check the hello Minie at the source level. We will actually open the build the gradle, and then you will find the bear and no, which is the native. This is the dependency for the native of Minie. So we actually delete this, then we sync. We do it again. Then how we check, we have the ANO and the bear files. We will close this and open the external libraries. This is the first way to check if the native binaries of third-party dependencies are actually bundled with your Android APK. So we will type Minie, and you will find the Minie bear files. And there is lib folder, and those are the architectures for Android from ARM64, ARM32, and the desktop Android binaries for Intel. Those are to work with emulators and Android x86 project. So we don't find here the natives, and this file is actually ignored on Android. The native file is actually it's not for Android. So there is no the actual ANO. It seems to be broken from the remote repository. So moving on to the second way to know this. The second way to know this is here from building the APK. So we will first we want to actually build an APK for the hello Minie module. So first of all, we will actually clean our project. Then after cleaning, the project is done. As you can see, the build file here disappears. Then we will actually rebuild an APK, and we want to see the process. It's now working at hello Lemur, hello Kotlin, hello Jimmy surface view. It's working through all your modules and building APKs for each module separately. Here we go. The build is successful. Now navigating to the hello Minie at the build, you will find your outputs. Then you will navigate that to apk-debug and hello Minie-debug.apk. That is our bundled APK. those are our classes. Dexit. I don't know why Android Studio is not opening these dex files. It was really opening. I did actually open one of these dex files before, and I found something like a commands based on Java. So they sent commands to the actual Dalvik virtual machine to execute your code. Anyway, those are the dex files. All your Java classes are included within these dex files. There is a functionality to enable multi-dex, where you have multiple dexes, and there's another functions where you can disable these this multi-dex. Anyway, this is the root folder of your application, and the source main. Anyway, forget about this. This is your root source of the application. Everything at the resources goes here into this. Wait a minute. Everything at the resources, at the Java resources, goes here into the root source of your APK. So, for example, the jMonkey engine resources file, it's all copied to here. So you'll find interface fonts. Those are things from jMonkey engine, by the way. Oh, it opens here, so you can open the dex file here. Yes, this is. You can open now the dex file, and you find it open downward. So let's see if we can find our class here. Come. Are the same silicas. You will find it in another dex, in the other dex file. Yes, this is our package, and those are our classes there, the main activity and our game. You will find the C in the constructor initiate and the initiate of your actual. You can show the bytecode. This is the bytecode. This is the actual commands for the bytecode is sent to the Dalvik virtual machine. Anyway, you get the point. Now everything is copied here to the root source of your APK, including the lib file, where you find your own your bundled native files. So for ARM64, we will find lib openal soft jme. This is for sound, and lib decode jme. This is for decoding file. So it's covered for every architecture. Here you have the own build for architecture, but here is something you have missing Minie here. So you are actually adding the native dependency here, but it's missing at the build, so it's not actually added. This is broken anyway. This is broken because it's not actually there. So if we actually had deleted the actual jme3 Android native here, if you navigated here, the external libraries, we type here jme3 Android. jme3 Android native. You will find a lib folder, and inside the lib folder for each architecture you will find its own build of the actual shared library. So if we actually remove remove this, then we synchronize. Actually have disappeared now. We'll clean project. So it's still there because of others. We can't build because it's not included there. We must include it. So at least we will have the Android only, not the Android native. The Android native module includes both the Android native and the Android. This is still there because others are using it. So this is the external libraries of the whole project, actually, not just this module. So we will actually clean the project. Then we will build another APK and recheck this back. Now it's building now. And here we go. We'll check it again at the outputs, at the APK, at the Minie. Now we will check. So as you see here, I can't find the lib, the actual lib file. There is no lib folder there because there is no actually a benefit from creating an empty folder at the APK. We have removed the actual JMS3 Android native, so now the lib folder, the lib is actually empty, and you can actually create the lib here the same as this project. You can create an internal lib folder and place your native binaries there as local project. So inside this project, this is Arithmos wrapper, for example, a template for Arithmos. Arithmos is a JVM and native algorithmic library. It uses natives, some stuff like B-threads and message queues, etc. Anyway, you get the point. We have the dependencies, and then we have Android natives module jar file, and inside that we have the library, the library file. It actually gets merged. It actually gets merged inside the actual APK library folder. So this library folder gets merged into the APK library folder, leaving off the dependencies, these dependencies at their respective architectures. So this is the same case here. If we want to if we actually build the final shape of our APK, would be under library, and we have our native files here. If there's another third-party dependency that has its own native files, it will be copied at their respective architecture here. So this is the second way. So the first way is through the external libraries. If you are actually using a Gradle dependency. And the second way is through building your APK and checking the internal of the APK and see if there is an actual library. The third way is through runtime environment. Is you actually during runtime you check if there is an apk, if your apk contains the native binaries, if your apk is bundled with these native binaries. Even without running jMonkey engine, you can do this on your main. So let's just fix these errors. You can do this through your main activity. You can actually do this through an static initializer, in which you load the library before anything, and even without actually loading jMonkey engine, you can check this. So this is that's it. It's very easy to do. So if we want to actually check for jMonkey engine, let's do this. jMonkey engine Android native, and we want to check if our application is bundled with lib-decode-jme and lib-open-al-soft-jme. What we will do, we will actually navigate to our main activity, then add a static initializer. The main activity is the entry point of our Android application. We will add a static initializer and just delete all this. We'll delete the actual all this, removing the jme surface view code and changing the load library to decode jme, for example. So if I run this, if I were to run this template, if the decode jme is actually present inside inside my apk, it will not raise an unsatisfied link error. But if it's not there, it will raise an unsatisfied link error that decode jme is not actually there. This is a classical shared library not found Java exception. So you get the point. Thank you for joining me, and see you later.